relevance of drawings to engineering, and what is vital about any engineering function is the idea of communication. So what we are trying to do is to provide information, and because it's difficult to describe something in words, sometimes the format of drawings is much more convenient, indeed much more informative, and I would say much more precise. Welcome to Hugh, who's just joined us. I have started, but we haven't really got into any detail at the moment, Hugh. So I will repeat what I said to Hiro, and that is, please, if you have any questions about what we discussed, please ask them, and I will do my best to answer them. I appreciate that sometimes they lead on to discussions which are relevant, and so we'll try to bring those issues out. So I think we can agree that this comes under the general heading of graphics, whether it's a diagram or a drawing. And one question I would ask is, what is the difference between a diagram and a drawing? What do you see as that particular difference between a diagram and a drawing? How would you define that? Pause for thought for just a moment. You'll notice that what I'm trying to do is to get you to provide a definition. Definitions are important because then there is no ambiguity. We all know what we're doing. And the one thing about a drawing or a diagram is it should reduce ambiguity by describing something which is unique and with a recognizable picture. And this then becomes the most effective way of communicating if we're dealing with an object and we want to show somebody what that object is, or indeed what it does, or how it works, or how to construct it. All of these ideas are, graphical in the concept. And you can describe something with a lot of words, but actually when you see it fit together, then this is the best thing. So I would say that a diagram is a representation. Oh, okay. Well, that's an interesting. You say a diagram is more general compared to a drawing. Well, that's an interesting way of putting it. But a drawing, I would define as something which is a view of an object, whereas a diagram explains something functional about the object. Okay, so a drawing is a representation, whereas a diagram is a functional analysis of the device. And drawings and diagrams are certainly not the same, but we tend to use the word drawing or diagram when we mean the other. So I will try and be precise about this. Who uses diagrams and drawings? Well, engineers and technical people, because it is a form of language. The basis of it is for the conveyancing of ideas and for concepts, and it's needed for the execution and completion of a project. So we can say, well, it's necessary for construction or assembly, and when we're dealing with individual components or parts of a device, then the drawings for those components build into the drawings and diagrams representing a system. So components and all systems is important here. And it's certainly a point of reference. Everybody comes back to the drawings and the diagrams to see what's going on because they're used in problem solving, again during design, manufacture, but also I would say during maintenance and inspection functions, which is so vital. So I think that's an important start. Drawings and indeed diagrams are certainly tools that engineers use, and they're used at various stages of the workings of a system. And I suppose 4 key stages are the tendering stage, help in procurement to get an accurate quote, you know, and you know, avoiding future disputes arising out of discrepancies. Principally because, you know, there's no information, there's no definition, but if there's a definition of what is required because there's an actual drawing or a diagram representing it, then it's clearly then it's much clearer. The design and the engineering stage, then clearly this is where the development of the drawings takes place. And that expansion keeps going right through to the construction or assembly stage. And then once you have the project, then you are of course required to operate the project and maintain the project. So drawings have to bear in mind what information will be necessary at that stage. And so there's definitions there, which I hope will support those main headings. Okay, so the idea really is that when an idea is conceived, a drawing is done, and that drawing is developed during manufacturing. It's provided with a finished product through the distribution channels. It goes to customers. Customers then have this habit of wanting changes and improvements, and that leads itself then to the modification of the drawings and the development of more ideas. And so there is very much a cycle of activity taking place within a manufacturing organization, so things are constantly changing. And one of the most important things in any drawing function is to accommodate and track the changes that will occur. It's interesting that if you do an audit on a company to see how well organized they are, one of the things you say is, okay, well, look, suppose this component changes. How do you deal with that change through from design and manufacture to distribution, recording, repair of the item? And by looking at how a company is organized, seeing how it manages change is one of the best ways to determine how cohesive the organization operates. And so certainly drawings and diagrams are at the heart of developments and changes. So we have to have good systems in place to make sure they are correct and accurate, properly distributed. And then we come to standards. Now, there's a lot of confusion about standards in some respects. What is a standard, and why are they necessary? Well, I think you'll agree that what we're defining with a standard is a technical specification. And it's not only for emerging technologies, it's also for well-established technologies. So if something is built to a standard, you know what you're getting. If that's the case, once you have an established standard, then it should reduce the development time and the cost. It utilizes sound engineering practices that are proven. So as a result of that development, but also trading costs are decreased because everybody knows what they're buying. You could argue that we are lowering trade barriers by saying here's a product that we offer, which is following a particular standard. And then there's the benchmarking of product quality, and the definition of safety issues, all of which require documentation and management. And of course there are some economic factors in this, such as the reduction of market risks, because people again know what they're dealing with, and indeed the protection against obsolescence. You've only got to look at the mobile phone industry to see how quickly product life cycles change. About 9 months is the average product life cycle for a mobile phone. So, what sort of drawings are there? Let's concentrate on drawings first of all. Well, principally, if a drawing is representing a particular item, then there are two-dimensional drawings. For example, key plans, plan layouts of buildings, again, drawings of structural design details, machine parts and fabrication drawings. And then we might need more details, so we have section drawings so that we can slice through a device and look at how it's constructed stage by stage. Clearance drawings to show what the separation is between various parts. And then we come on to schematics or wiring diagrams, tables and schedules, all of which support the construction and maintenance of equipment. Now, sometimes two-dimensional drawings aren't sufficient, and it is better, because of the complexity of a device, to show a three-dimensional representation. And again, we can see that in isometric, we can see that in a perspective view, and sometimes we can use solid and surface models, or what they will call wireframe models as well, which you can turn and twist to view different angles on, say, a computer-aided design system. So I think that amplifies that section well enough. So here is a sectional drawing, and you can see here we have a piece of equipment, a drawing for a piece of equipment, and in this case there is a section drawn on AA, and it is drawn below the device itself. So let me show you the examples of first angle and third angle projection. First angle projection is very often referred to as ISO or English projection, whereas third angle tends to be referred to as US or American projection. But here we have a section, and so which view do you feel this is using? Which projection are we using for this? Admittedly, this is a section drawing, but we can use the same argument. You'll see how if you look at the way that a solid object here is in the middle, you can then see that if you look at the front and you see projected at the back of the object the view that you see from the front, that's what we call first angle. But in this case, you see the object in the center and the views are at the front. So this view is at the front, so this would be a third angle projection. The reason this is important is that you must be consistent on a drawing as to which form of projection you're going to use, and you should declare it and make sure all the views are accurate. That can cause a lot of confusion if that's not the case. Here's a typical isometric view of a machine part. Isometric is drawn, generally speaking, with the angles from the vertical in 45 degrees to the baseline, and there is no perspective in such an issue. Mr. P. Makura has asked a question. Please ask your question. Do you have a microphone that you can use? If you do, I will switch off. If not, please type me the question in the box. Okay, please do that. I will stand by for your question. Yeah, when you say the standard is to use only one type of projection, what we're saying is that if a company is going to produce a set of drawings, then they should decide what projection type they're going to use. So it should say on the drawing, we used ISO or first angle projection. We will use a third angle projection, and they will declare that on the drawings. Hopefully this is something that is decided, that's declared when a project is undertaken. So, for example, if a company decides to bid for a job, then it will put its tender together, and in its documentation, it would state that its drawings are going to be in first angle projection, or the bid. The tender document issued by the purchasing company might say all drawings shall be used shall be produced in one particular projection mode. So again, there is no standard, there is no one authority that dictates that on every drawing it will be done in this particular style. There are industry standards, which are agreements between, say, purchasers and suppliers. And there are national and international standards. So when you say, so the standard is to use only one type of projection, you must ask yourself, what do we mean by a standard here? Is it convention or what? Do you see the point I'm making? This discussion goes on to state that when a project is, when you begin a project definition is important to ensure that everybody uses a consistent approach to documents, drawings, and diagrams. So the project document should declare how certain things are going to be communicated, and that becomes part of the operating standard for that project. So I hope that answers your question. Please come back to me if you want to discuss this. Well, yes, is it allowed to mix third angle and first angle? Of course you can do that on a drawing, but I would put it to you that you would confuse the reader of the drawing, whoever has to look at the information, because unless you make it clear where the views are, then the information conveyed by that drawing would be very difficult to understand. And I think it's worth saying now that you know, the whole point of providing a drawing is to provide sufficient detail for the understanding of what you're trying to convey. So that has to be done in a way that makes it easier for the reader of the document to understand that information. So yeah, there's no reason why you can't put little insets in one angle projection and other insets in other forms if it helps the reader to understand the document. Generally speaking, unless you're consistent, it's very confusing. Again, that's my view. I don't know if Hugh has a view on that, for example, but I think that's worth stating. Okay, good. No, I think these discussions are really quite important and things like that. So here's an exploded view of a bearing assembly. Again, this makes it much easier to understand how the system is assembled. Again, it doesn't convey to you how big the device is when it's fully assembled, but it will assist somebody to actually perform the assembly. So again, which type of drawing, which approach to drawing is best will depend on what stage you're at in the production of an item. And there are many forms of these, I'm sure you appreciate. So we come to discuss standards in a drawing office. This particular discussion assumes a formal drawing office. So on a large project where you've got a number of design engineers, the design engineers and the drawing office function work very closely together. and what a drawing office seeks to achieve are, we think, the following issues. First of all, the uniformity of graphic depiction has to be maintained, and this goes back to choosing what angle projection you're going to use. The second thing is then, only necessary information to be displayed on the drawings. There's no point in putting an awful lot of clutter on the drawings that are meaningless. Next issue is concerned with the dimensioning. Correct dimensions should be done, informative dimensions. And again, a lot of engineers put far more information on that is necessary because they think it's convenient, but actually it's potentially confusing to the reader. And again, standardized symbols, and I say that because when you provide drawings, you must declare what symbols you're going to use and what they mean. It's no good assuming that people know what symbols, what the symbols mean. You must make it abundantly clear. And if you're going to use an IEC standard, for example, IEC 617, which are defined within the electrotechnical vocabulary and other documents, then we want to use appropriate abbreviations and appropriate symbols which are familiar to everybody. So you need to declare that in a drawing office for a particular project. This is where we move to things like computer-aided design systems and computer-aided design system management. And again, there are established ways of using computer-aided design systems, and the main areas are, first of all, drawing control. Well, all the drawings that are produced are held in a central archive, which is then backed up, and for the purposes of looking at that archive, you need access for viewing so that people can go in, retrieve the drawing that they want, and ensure that they have the most up-to-date drawing. So, users must have access to a CAD system, and again, during the creation of drawings, these drawings are held in a private area. The point of that is that they cannot be released to the archive, to the central archive, unless they have undergone a process of completion and approval. So again, somebody's got to take responsibility for the issue of the drawings. That procedure has got to be done at an approval level which has the expertise to make sure that the appropriate information has been conveyed. So people who approve drawings have got to be competent. They've got to also have the technical competency and authority to be able to say, okay, this is acceptable, but that is not acceptable. And again, drawing changes is a very big issue. We all know what engineering creep is, the fact that, if an engineer can improve something, he'll do a modification. They like sort of getting things right, don't we? But sometimes the cost of constantly revising something is going to put its cost up. It's going to put its production capability up. So again, there must be a way of removing from an archive, causing a change, replacing with a revision, and then there must be traceability, there must be authority and responsibility in permitting a change to be done. So all of that has got to be managed with a computer-aided management design system. So we've talked a lot about drawings, but what are they? What makes them? What are they made up of? Well, the 5 key issues here is that you want a margin around a drawing. So for example, if I put a border around here, if you were to print this page and some of the edge of the page gets damaged, which is more likely than the center, information is not defaced. So you want border lines which define where the drawing starts. You need an orientation mark which tells us which way is up or which way is north. You then need a frame grid reference system so that you can find particular parts at certain coordinates. So across the top here you will have sort of A, B, C, and down here you will have 1, 2, 3. And these will mean that if you take a point here, you can refer to that as in area C3 of the drawing by looking at the appropriate cross-references. And then the north symbol and key plans to explain what the information is. So these two are vital information as well. So here's a sort of typical engineering drawing with the margin, the border, the grid lines, and the frame. The area inside this is called the frame. There's space for notes, and there's space for other information here, which is the reference block, as we've called it. And also there is an area here which is suitable for what's called a bill of materials, an inventory, or other listings that provide appropriate information for that drawing. So a form of a drawing could be a number of issues. For example, a block diagram is just drawn by a series of blocks that we sort of say here that if you're describing how a plant works, then you have a series of blocks here, and you say, well, in this case, you know, function A occurs, then the next thing is function B, whatever it is, and function C. So you can describe a process as a series of function block diagrams. It describes just literally functional relationships represented by blocks. With annotations, yes. Showing connections, if they're simple, yes. So I mean, if we're talking about a simple distribution system, then you could say, you know, a product distribution system. Then you say, well, lorries come in here, they deliver the product, it's stored in function B, and then it's retrieved in function C, it's packed and delivered. Now, how much detail do you show for that depends on who the drawing is being shown to. There are other issues. For example, with any block diagram system, you will then need to explain more about the functions of the blocks, and that's done on a textual document which is called a process description. So a block diagram can be fairly simple. The process description is literally a way of explaining what the blocks do and how they interact with each other. The third document that comes with this is called a mass balance. Now, this is a mathematical system. This is a mathematical document. Sometimes it's produced on a spreadsheet, and it basically thinks about, well, what quantity is coming in? What quantity is coming in here? Sorry, just change my drawing tablet function here. So, what quantity of product is coming in here? how much energy do we need to deal with that? So, you know, we might need, for example, gas. We might need electricity. How much electricity and gas are we going to need? What sort of capacities for storage? So we've got to think about storage. And I'm pleased to understand that I'm talking in very general terms here. But storage, delivery capacity, things like throughput. Sorry, there's a delay on my graphics tablet, which is making my writing particularly awful. Let me just type this down here. Sorry, bear with me for just a moment. Let's get rid of that. Sorry, the points I'm trying to make here, we're thinking about things like storage, capacity, throughput. If I could spell that right, it would be good. All of these issues concerning mathematical values go on a mass balance to be able to show their relationship. You know, if we're making in chemical manufacture, for example. So in support of block diagrams, process description and mass balance. But in creating these block diagrams and text, we begin to define things like the boundaries of a system, what it can and can't do, how much space we need for it. We need to be able to define the inputs and the outputs of each part, and indeed the relationships between each part in general terms. You know, for example, if product B is being heat treated, then do we need an area where the heat treated product is allowed to cool before it then goes on to C? So do you see, block diagrams can have all sorts of information in them, which we then have to control.